We've got a truck here dragging 2 logs along the ground. Each log is 600 kgs, that's its mass, and each log experiences a retarding force, a backwards force of 500 newtons friction with the ground. The connections between the trucks and the log are made with ropes that have a braking force 2,400. Tension 1 is here, tension 2 is here. Calculate the magnitude of tension 1 when the truck's moving at a constant speed. Right, the way you calculate this, excuse the cars outside, is I'm going to look at the system at the moment. I'm going to look at this system here. Okay, input into the system is my tension 1, which is pulling this way, and output is 2 lots of 400 newtons. And when everything's going at a constant speed, the total force equals 0. And if these are pulling backwards within the system 400 each, then this must be pulling forwards with 800 to cancel it out. Forwards to cancel out my 2 400s backwards to give me equals 0. So the tension, the first one must be 800. The truck now accelerates at a rate of this. They've given me acceleration. Calculate T2. What I'm going to do for this one, I just want to work out T2. I'm just going to look at, let's do it in another colour. I'm just going to look at this system here now, because that has T2 in it. Now T2, if we've got this system, we've got the block, we've got T2 here, and we've got a backwards force of just 400 newtons. Right, what's the total force on this block? Because it's accelerating, it equals MA. So it equals 600 kgs, because we're just looking at that one block, times the acceleration of 0.5, which equals 300 newtons. It's accelerating, so it's that way. So total force is 300 this way. It's made up of its actual forces of tension plus backwards 400. So what does tension equal if when we add it to 400 backwards we get 300 forwards? The only way it can work is if it's equal to 700, it's bigger than the 400, because these partially cancel out and you're left with 300 this way. So this is your tension, 700. At another point in time, the driver observes the speed of the truck is 4. The truck then keeps accelerating at 0.5 for another 20 meters. Calculate the speed at the end, final speed. So this must be, this is the initial speed. So we've got all these. We've got U equals 4, A equals 0.5, X equals 20, and V equals question mark. The equation of motion that has all of these in it is V squared equals U squared plus 2AX. So put all the numbers in, 4 squared plus 2 times 0.5 times 20, which equals 16, plus 2 times 0.5 is 1 times 20 is 20, which equals 36. So that's V squared equals 36. V equals the square root of 36 equals 6. And the last one of this series, open 5D. Right, I've copied and pasted the picture again and the instructions of what's going on. The 2 ropes have a braking force of 2,400 newtons. Rope 1 connects here, rope 2 connects here. The truck, still on level and ground, increases its acceleration until one of the ropes is about to break. Identify which rope is about to break and calculate the magnitude of that acceleration. Well, the easy part is which rope's about to break. This one only has to pull one of them, and this one has to pull both of them. So this one's going to have the most tension on it, so we know the answer is rope 1 is going to break first. Then we have to work out the acceleration that this happens at. Because we're dealing with rope 1, just like in question 1 I think it was, or question 5a, we dealt with this system. Alright, let's have a look at that system. We've got outside the system, we've got 2,400 pulling that way. We've got two lots of 400 pulling backwards. So the total force on the system equals 2,400 minus 400 minus 400 equals 1,600 newtons. Now we can work out the acceleration, because that's all they want us to find, by saying total force equals ma. So A equals total force over m, which equals what we just found, the total force, 1,600. Because we're looking at this system here, around here, the mass is 600 and 600 is 1,200. 1,200 kgs. And calculating that is 1.33 meters per second squared.